Alright, so this is the fourth video, and this one's going to cover domain, range, and some parent functions, and just functions that you need to know cold, know exactly what they look like. So for these problems here, we've got some domain and range questions. This one says f of x is the square root of x minus 2. So something that you should know cold is the square root of x. It starts here at the origin, has some curve to it, goes up real slow, goes up forever, but it has this look to it. When you subtract 2 inside the square root, what happens is this gets pushed 2 to the right. So this is getting this guy to move 2 forward. You could double check that, just throw 2 in to your function here, just do a little t-chart. 2 minus 2 is 0, so you're at 2 comma 0 right here. So again, the original one had 0, 0, but this one gets moved to the right. So again, the original domain for just square root of x, you could see domain, remember, is all of the x's. So for the square root of x, the domain is x is greater than or equal to 0. The range are the y's, so the range is all y's greater than or equal to 0, because this thing starts at y equals 0 and just goes up. The x's start at 0 and go right. So what we've done for this problem is, since we've moved the function over to the right 2, the domain is x is greater than or equal to 2. But since we haven't moved the function up or down, the range is just y is greater than or equal to 0. Like, that hasn't changed it at all. For the next one, we have a parabola and a plus 4. So a basic parabola, you need to know cold. That's this thing right here, looks like a U. And the original domain for this is all x's. So you can see all x's, so you can put all real for the domain. And the range are just the y values, so only the positive y values are there, and 0, so y is greater than or equal to 0. That's for the original x squared. But for the x squared plus 4, what we've done is move the function up 4. So that's what happens. So if you've got it inside, like the square root, or if we made this thing like x plus 4 quantity squared, that would move this function to the left 4. This one moves the square root of x to the right 2. But for this problem, we moved it up 4, so the domain has not changed. All of our x's are still in play, so the domain is all real. The range has changed, though, since we've got this right here being the original function. We moved it up 4 spaces, and now the lowest y that we've got is 4. So our range for this problem is y is greater than or equal to 4. Alright, ln x, this is natural log x. This is something that you may not have seen for a while, but you're going to use it quite a bit in AP Calculus. This is what ln x looks like. You see it never hits 0 for x, ever, and it has no negative x values over here. So the domain for just this function here is x is just greater than 0, not equal to 0. There's a vertical asymptote happening right here on the function, so it never hits x equals 0. So it's only x is greater than 0. The range are the y's, so all y values are accounted for. Everything exists. So the y's, you could just say, are all real. So the range is all reals. So e to the x, this is the inverse function of ln x. So this is the exponential growth function, starts low, goes up real quick. You can see all x's in the e to the x graph are accounted for. So the domain is all real. And the range, so you look here, there's a horizontal asymptote happening. So it never ever gets to y equals 0. It gets real low, but it never actually gets to 0 for the y. So the range is y is just greater than 0. You see this is a switch. The domain becomes the range becomes the domain, and that's because ln x and e to the x are inverse functions, and that's a property of what inverse functions do. Alright, and you should be able to draw a real quick sketch of any and each of these functions here, like square root of x, and it starts here at the origin and kind of has this shape to it. It doesn't need to be perfect, like x squared just has a U shape. And you could always make a t-chart like this and just plug in values like 1, 1, 2, 4, just like you did in 7th or 8th grade. But for calculus purposes, you just need to know like the basic shape of these things. Like x cubed should be like a S kind of shape. X, this is just linear, so this should have a slope of 1, something like this. Okay, 1 over x, this is one where you actually might, for now, make a little t-chart and kind of see what happens. Like if you put a -4 in, see where you're at. Well, your y would be -1/4. So it'd be here and real tiny here. If you have a -1, your y value would be 1 over -1 or just -1. Be here. If you made a -1/10, 1 over -1/10 makes a -10. So what's happening, this is really small this way. So it's gonna look like this. And on the other side of it, since x can't be 0, you'd create a vertical asymptote here. It's gonna be this opposite look here. But make a t-chart and you can see for yourself. This is kind of the basic shape of 1 over x. Tangent, if you remember from pre-calc, has vertical asymptotes at pi over 2, and starts like this. Again, it doesn't need to be perfect, just to have a basic idea of what these graphs look like. Absolute value x, remember it looks like a V, so it should have a sharp turn. Sine starts at the origin and goes up, down, up to 1, down, and then at pi over 2 should have a -1, like this. Cosine starts up at 1. So let's think this through. Right here is going to be 0. At pi, you can use your fingers. Hopefully you've learned that trick. Cosine pi is -1. 0 here, and we're back to 1. So it has this curvy shape. Like that. So e to the x, we did this on the other page. It starts low, goes high. So like e to the 0, anything to the 0 power is 1. So it starts real low, but goes up quick. 2 to the x is pretty much the same thing as e to the x. Like 2 to the 0, we're at 1. So we'll literally have the exact same shape to it. Almost nothing different. And then natural log x, this one has a vertical tangent at 0, and it just starts real low and then grows real slow like this. Okay, those are the basic shapes that you should be familiar with.